Now, as you can see that the connections between the physical layer and the another physical layer of the link 6 we have established here. So this when the connection, we just imagine the bit stream is just going to be the basic issue that has been just make a transmission with this each of the layers. So the computer is sends each bit of router 1 R1 in the format of the protocol used by link 1. So there is a format that has been used by link 1. The router 1 sends each bit to the router 3, and they will also send the same format dictated by the protocol and used by link 3. And if a node is connected to n number of links, it needs n physical layer protocol. So each of the links that they go through to that, each of the physical layer will they pass. Now the data link layer, TCP IP does not define any specific protocol for the data link layer. So first of all, the network access is the main layer. We have just imagined for the TCP IP TCP IP layers for physical and data link layer to understand it. That's because we know the OSI model very popularly. So it supports all of the standard and proprietary protocols. At this level, the communication is also between two hops or nodes. The unit of communication, however, is a packet called frame. So that is the thing. In the data link layer, we just get the bit streams, make it to the frame. So there may be a header and trailer to make it a frame. So a frame is a packet that encapsulates. Encapsulates means to make a capsule of information of a bit. The data received from the network layer with an added header and sometimes a trailer. So there is the added header and sometimes a trailer, just to understand where the destination address and where the source address, right? And the head includes the source and destination of frame. So the frame, if it is a frame, so head includes the source and destination. The destination address is needed to define the right recipient of the frame. The source address is needed for possible response for acknowledgement, as may be required by some protocols. So now the layers has been increased, as you can see. So now there is no bit streams, just encapsulating capsule on each type of part. As you can see, there in another data link layer has been established. So the frame that is traveling between computer A and router R1 may be different from one traveling between router R1 to R3. So now different hops, different links will establish different type of things that you can see. The frame may be different. When the frame is received by router R1, this router passes the frame to the data link layer protocol. The frame is opened, the data removed. The data are then passed to the data link layer protocol to create a new frame to be sent to the router R3. So each and every path, when they pass, they will be encapsulated with different type of header and trailer, and that will show that which path they came in and which path they want to go. So that will be the path, that will be the thing of the router is that make a connection with that fails, that just after that fails its step, that whether it came, and you can see the footsteps throughout the network. And at the network layer, or more accurately the inter-network layer, TCP IP supports the internet protocol. The internet protocol is the transmission mechanism used by TCP IP protocol. That is the thing. The TCP has been slashed by the IP protocol names. So the IP transport data in packets called datagrams, each of which is transported separately. Datagrams can travel along different routes and can arrive out of sequence or be duplicated. IP does not keep track of the routes, the routes, maybe not routes. Router and route is different for the, as you can say, pronunciation issues. So IP does not keep track of the routes and has no facility for reordering datagrams once they arrive at their destination. So they just make the routes by the datagrams. Now the link has been totally established in the network layer. As you can see, there is a single destination and single source. In that particular point, there is a single destination and a single source, but previously there are different destination and source for each of the path they arrive, each of the router they arrive, each of the link they arrive, they just put through to their footsteps. Okay, that whether they will come or not. So now you can see there is a connection, there is a connection that has been made through to it. It's been made through to it, through a total connection that has been made through to it, through the routers, through the source and destinations. Okay, so now, so this is the thing the datagram to datagram connection is all about. Now the network layer, in the network layer, now just going through to another network another part, that what is the main difference between the communication of network layer and the communication at data link or physical layers. The communication at the network layer is an end-to-end communication, and the other that means network is end-to-end communication, that means that establishes the network between the destination computer and the source computer, while the communication at the two layers are node to node, because they are still node to node. If you see the previous figures, the source to destination has been broken into separate parts because they have gone through to a separate path, that computer to router 1, router to router 3, router 3 router 4, router 4 to router 6, and then they make a connection with the link 6 computer, just like this. That is the node to node communication. But when they come onto the network layer position, network access will check the access and make a direct access for it. Now they are connected to each other. That's the thing. So what are the issues of transport layers now? Now there is the part of the service that comes around. So the main difference between transport layer and network layer is that all nodes on a network need to have the network layer, because network layer will establish a network between these two end-to-end computers, but they need to have the transport layer. Why? Because there are some segmentations, there is some tunneling, there is some channel and needs to be created between these two to make a proper flow of the data. The network layer is responsible for sending individual datagrams from computer A to computer B. The transport layer is responsible for delivering the whole message, which is called segment, a user datagram or a packet from A to B. A segment may consist of a few or tens of datagrams. The segments need to be broken into datagrams, and each datagram has to be delivered to the network layer for transmission. So datagram has some acknowledgement issues. They go through to each of the part, and similarly when they establish the network, when A and B or 1 and 2, 1 or 6 links has been connected, establish a connection. So they will just when they communicate with each other, the total data will be divided by some segments. They are known as datagrams. So that is gonna be flow through whole of the network. Okay, and from the beginning of the source to the end end-to-end connection of the destination address, they just acknowledge that what they want to know and what they want to know, what you have to know actually. So that is the end-to-end connection. So transport layer is like that. So they just reassemble and make a tunneling approach to make a direct connection and just flow the data through to them. Now this part that really makes the difference between some parts, that is the why this is TCP IP. So transmission control protocol is a reliable connection oriented protocol. That is a connection oriented protocol that makes a real connection, real network access between two individual hosts. And also the TCP also handles flow control to make sure that a faster sender cannot swarm a slower receiver with more messages that it can be handled. So flow control is one of the basic part of that. So it is widely used. User datagram protocol is also a protocol, but it's unreliable connectionless protocol for applications that do not want to TCP sequencing or flow control, wish to provide their own. It's also widely used for one slot, client server type request reply queries. HTTP is widely used now. At last, the application layer. So application layer is a TCP IP equivalent to the combined session presentation and application layers. So in the OSI model, same as the previous one, there's an end-to-end connections, and your computer will show up the electronic mail, file transfer, and World Wide Web, and so on, whatever else you are connected with another computer. That's the thing in the application layer, and that's it for all for TCP IP layers.